What is Gay-Lussac's law? Gay-Lussac's law is a gas law which states that the pressure exerted by a gas of a given mass and keep it at a constant volume varies directly with an absolute temperature of the gas. In other words, the pressure exerted by a gas is proportional to the temperature of the gas when the mass is fixed and the volume is constant. What is the difference between Charles' law and Gay-Lussac's law? Gay-Lussac's law and Charles' law has a very similar, with the only difference being the type of the container. Whereas the container in a Charles' law experiment is flexible, it is rigid in a Gay-Lussac's law experiment. What did Gay-Lussac's law attribute his findings to Jacques trials? Gay-Lussac's law did attribute his findings to Jacques trials because he used much of Charles' unpublished data from 1787. Hence, the law became known as Charles' law, or the law of Charles and Gay-Lussac's law. Amonton's law, Charles' law, and Boyle's law form the combined of gas law. What is an example of Gay-Lussac's law theory? For example, Gay-Lussac found that two volumes of hydrogen and one volume of oxygen would react to form two volumes of gaseous water. Based on Gay-Lussac's result, Amedeo Avogadro hypothesized that at the same temperature and pressure, equal volumes of gas contains equal number of molecules. Avogadro's law. Fun fact about Gay-Lussac's is he known mostly for his discovery that water is made of two parts, hydrogen, and one part of it is oxygen. With Alexander von Humboldt for two laws, discovery that water is made of two parts, hydrogen, and one is oxygen. With Alexander Humboldt for two laws related to gases, and for his work on alcohol-water mixtures, which led to the degrees Gay-Lussac's used to measure alcoholic beverage in many countries. So this is the formula of Gay-Lussac's law. And this is the example image of Gay-Lussac's law. So we're going to have an example on how Gay-Lussac's law works. So first is we're going to have a candle, a cup of glass, and water, and a plate.
Lastly, take your jar or a glass and place it over the top of the candle. After how many seconds, while having our jar over the candle, you will notice the candle's flame will get smaller and smaller until they are extinguished. Also, you will see that the water level underneath the jar begins to rise after the light from the candles have been fully extinguished. The water outside the jar is lower than the water inside the jar.
Thus, the Gay-Lussac's law applied in the experiment. The jar is placed over the candle, so when the air is heated, the gas particles expand and move faster, putting pressure on the water that has a higher temperature is equal to higher air pressure. That is stated in the Gay-Lussac's law, where pressure increases proportionately to temperature increase. Carbon dioxide, a product from the chemical reaction, pushes oxygen downwards since it is hotter. As more carbon dioxide is produced, there is less oxygen available for the combustion causing the flame to go up. This lowers the temperature of the air, applying the Lusaac'S Law, and there is now